yesterday's work, the Pythagoras and the area stuff. I know there was some tricky questions in there. If we get a chance, we will go through some of the harder ones at the end if we have some time. Now we're going on to surface area, and both of the exercises that we're doing today are on surface area. This first one is on prisms and cylinders, so you should be fairly familiar with these formulas. So a rectangular prism, formula here, SA for surface area equals 2 lots of LB plus LH plus BH. Okay, it doesn't matter which one's LB and H as long as you are doing all three combinations of multiplying those side lengths together. A cube is 6 lots of L squared, or some people might, does anyone use X? X squared? Yep, you're welcome to use X, that's fine. 6 lots of whatever the length is squared. A triangular prism doesn't have its own formula per se, but it is always 2 triangles. You're always going to start by finding the area of 2 triangles plus the area of 3 rectangles. Now, if all 3 of those rectangles are the same size, that makes it easy. You just go 3 lots of whatever the base times the height is. That would be if it was an equilateral triangle. But you might only have 2 rectangles the same or no rectangles the same, and you might have to do 3 completely separate rectangles there for that. The 2 triangles, though, because it's a prism, will always be the same. And finally, the cylinder. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now, just so that you are aware, the 2 pi r h is the body or the tube part of that cylinder, okay? Oh. The 2 pi r squared is the area of a circle, isn't it? So 2 of them means there's 2 ends, there's 2 circles on the end. So if you ever got a question that said you have a completely open cylinder, you would not use the 2 ends. Okay, you would just do the body part of that formula. All right? Okay, good. These are the examples down here. That says ends. Very messy writing. Sorry about that. Okay. Question 1. Find the surface area of the following. So where possible, we want to start by writing down the formula. So the formula is SA for surface area equals 2 lots of LB plus LH plus BH. Okay, that's straight out of the box up the top. However, you will notice that when I handwrite it, I prefer to write it in capitals because otherwise my L's tend to look like 1s, and you don't want to get confused there. So you're welcome to do the same thing as me. I use capital letters in there for that. Okay, so substituting in. You can choose which one's the length, the breadth, and the height. I'm going to go, this one is my length, this one is my breadth, this one is my height. Okay, it doesn't matter if you do them in a different order though. Okay, so 2 lots of length is 15 and the breadth is 12 plus the length is 15 times the height, which is 4. What is that? Maybe we won't hear Mr. Melody out so loud. And lastly, the base times the height or the breadth is 12 times by the height, which is 4. Okay, then just type it all in your calculator. Don't try and do anything of it in your head. That'll just slow you down. That is 592 centimetres squared. It's still area, so there's still centimetres squared. Everyone got that? Ready for me to keep moving? All right. Yes, got it? Yes, got it? Yep, good. Okay, question 2 on the next page. When you look at the shape, you have to identify that is a cylinder. So the formula for a cylinder, always assume, maybe just close the windows to cut the noise down. I know that's probably a bad idea, but save some of the noise. A little bit better. Yay. Okay, so the surface area formula of a cylinder is 2 pi r squared for the ends plus the 2 pi r h for the body. Okay, always make sure that you do have the radius. In my question, I've got 5.4 there, but that's the diameter. It's going the whole way across. So straight away over here, I'll make myself a little note. The radius is going to be half of that. Half of 5.4 is 2.7. Okay, the 3 is the height. Okay, so now we can substitute those into the formula. 2 pi times 2.7 squared plus 2 pi times the radius again, 2.7 times the height, which is 3. Okay, and I'm going to stick to 2 decimal places as my default here because it hasn't specified. We know we need to round. Did anyone get an answer for that? No? You want me to tell you, don't you? Yep. 96.70 meters squared, and that's my 2dp. Question 3, still doing surface area. By the way, in this topic, when it comes to the test, make sure you read the questions. Sometimes it's easy to go, oh, there's a triangular prism and you might do volume and it actually said to do surface area. So make sure you do actually take the time to stop and read which one you're meant to be doing because you unfortunately lose all your marks if you're doing the completely wrong type of question. Okay, so take the time. We're doing surface area at the moment. So the surface area of a triangular prism, we have to kind of make up our own formula for. We know there's going to be 2 triangles. Okay, the triangles are the same. So that's 2 lots of, the area of a triangle is half base times height. Okay, then we know we have 3 rectangles, but are the 3 rectangles going to be the same size? Or are any of them the same size? No, all 3 of them are different. I have 6 for the length of that one, 5 for the length of that one. Ooh, and that slopey one's a bit of a problem. Okay, so at the moment, they're all different sizes. So we're just going to go plus BH plus BH plus BH for the 3 different rectangles. Now, algebraically, that's a bit of a nightmare because each of those B's, if we look at that, we would think that they were all the same, but we know that they have to be 3 different bases and 3 different heights, right? But I don't have 3 different B symbols to use and 3 different H symbols to use, so that's why I have to write it like that, okay? But you know what that means. So now looking at that question, let's see if we can substitute into it. So I have got, for my triangle, the base and the height. Find that right angle. The base and the height is going to be the 6 and the 5. Okay, so 2 lots of, there's 2 triangles. Half the base is 6 and the height is 5. Now, rectangle number 1, I'm going to make it the one on the bottom. This flat one down the bottom here, what it's sitting on. The base and the height of that would be the 6 times by the 14, going back down the base there. So the first rectangle, 6 times 14. Second rectangle is I'm going to make it this one here on the side. 5 would be the length one way, and again it would be the same distance going back as the last one, the 14. Okay, so 5 times 14. And that leaves me with my last rectangle, which I said was the problem one. Okay, I know for this sloping rectangle here, I know it's 14 across here, but I don't actually know this side of my rectangle. Can anyone think of a solution? Yes? Pythagoras Theorem, absolutely. Okay, on the front here I have a right angle triangle and I have these 2 sides here. I can use Pythagoras Theorem to find that third one there. So I'm going to do a quick little, let's do a calculation here to find that one. To use Pythagoras Theorem, it's the hypotenuse I'm finding. I'm going to sub straight into the formula. It's just going to be the 2 shorter sides. 5 squared plus 6 squared. Now, that's going to be a decimal number. I don't want to have to put a rounded number into a calculation. We've learnt a bit about errors, right? If I round this and then I do lots of timesing with it, you might be out by a few decimal places from your final answer. So instead, to avoid an error here, if I leave that in surd form, so 5 squared plus 6 squared is 61. So I'm just going to put in the square root of 61 just so I keep it exact. Your other option is, if you do prefer to have the decimal, you don't like working with the surd there, that you could just in your calculator, keep all those decimal places so you know you're not entering in a rounded number too early. Okay? That way, if you are, like if you rounded it to one decimal place, when you look at your answers in the back of the textbook, you might be out by a few decimal places, okay? And that's why, because you've used a rounded answer. Okay, so for my last rectangle, it is the base, which is the root 61, times by that length there, which is 14. Okay, and I just type that whole big line into the calculator, and you get 293.34 centimetres squared. Again, that is rounded to two decimal places because that square root of 61 is a big decimal, a long decimal. All right, question 4. Find the surface area for the following. So we're combining a couple of shapes here. I have half of a cylinder on top of a rectangular prism. Be careful. If I use the rectangular prism formula, then I've actually got, I don't want to count this side that's connecting the two. Okay, I don't need to count this bit in here. So I actually would need to take off that side from the formula. So instead, you could do each of the rectangles separately. So I could do this kind of thing. So I'm going to go surface area equals, I'm going to have the two rectangles on the ends. So 2 lots of BH for the end rectangles. I'm also going to have 2 rectangles. So let's go B is this one, B and H. I'm also going to have, what was my other symbol I should be using? L. This one's going to be L. I'm going to have 2 lots of L times H. But I'm only going to have 1 L times B. Yeah? Okay, I have 2 of each of the side ones, but I don't have that one bottom one for the rectangular prism, which is why I haven't used my formula. Your other option is to use the formula, but then take that extra one off again. That would also work. The cylinder. If I was to halve the cylinder formula, is that going to work? Yeah, it is. Okay, because I was never counting a flat side in there for that cylinder anyway. So I'm just halving that curvy body part, and I'm halving the 2 ends. So that works just fine. So let's just go half. The formula for a cylinder is 2 pi r squared plus 2 pi r h. All right, sub it all in. 2 lots of base times height, which is 20 times by 15, plus 2 lots of L times H, which is 50 times by 15, and the BH, the one on its own, is 20 times 50. Okay, that's my rectangular prism parts. Then I have my half of a cylinder. So half at the front. What is my radius? I haven't checked that yet. 10. So the 20 is telling me that part there, which is the diameter. So that means that the radius is going to be half of that is 10. Lots of little things to be careful of this in this question. So 2 pi times 10 squared plus 2 pi times 10 times what is the height, which actually is a different symbol. What's the height of the cylinder? The 50. It's the long one going back here. These symbols that I used here were just for the rectangular prism, so don't go and think it's that H there. The cylinder, the height, is actually the 50. Were you going to tell me the answer? Nope? You had a question.
I have a question.
Yeah?
Do we have to take away an area of a rectangle?
No, because I did 2. I took 1 off already, basically, by only doing 1 here. So I've got 2 of the front ones, 2 of the side ones, but only 1 bottom one. So if you want to do the takeaway option, you could use the whole rectangular prism formula and then just subtract 1 off. That would also work. Okay, so my answer is 4984.96 meters squared to 2 decimal places. Okay, so that means that you can do exercise 1E there, but keep flipping over the pages until we get to 1F. Also surface area, but these are the lesser known shapes. These are the pyramids and cones. Now, the surface area of a pyramid, unfortunately, again, we don't really have a set formula because sometimes it's a square-based pyramid and sometimes it's a triangular-based pyramid. Okay, so basically all you need to do is find all the areas of all the sides and add them up. Usually, you'll have one shape on the bottom that's either a square or a triangle, so you have the base shape, and then you will have 4 triangles, or 3 if it's a triangle on the base, going around the outside. That will all be the same size. Okay, so that will make it easier. You just do 4 lots of those triangles. So for this one, we have area of the base plus 4 triangles around it. Okay, a cone does have a formula. Okay, my thing changed my pi symbols to p's. Silly thing. Let me change those back. Okay, so the formula for the surface area of a cone is pi r squared, which you're probably already thinking in your head. That's the circle part that's on the top, isn't it? Pi r squared. That's a circle on the top of that cylinder, of that cone. And the pi rs is what we call the curved surface. Pi rs. Yeah, that's slant. So we use s to remind us that it's actually a slant height. Okay, when we do volume, if you might remember volume from before, we do use the normal h, the perpendicular height, but surface area is the slant height, so it's the s there. Okay, so you have to be careful to make sure you use the right one. Example number 1, find the surface area of the following. The first shape is a cone, so we write the cone formula down. Surface area equals pi r squared plus pi rs. Do I have the slant height? Yes, this one here is the slant height, the 12. The 9 is going to be my radius, so I have everything I need. I substitute it in. Okay, so pi times 9 squared plus pi times 9 times the slant height of 12, which is 593.76 centimeters squared to 2 decimal places. Am I going too fast for anybody? You're okay? Part B, it is a pyramid. Okay, so for the pyramid, we know that we're going to have the base shape. What is my base? A square. Okay, the base of that pyramid is a square. So what's the formula for a square? You're either using x squared or L squared. I don't mind which one. Then I have got 4 triangles going around that. So I can go plus 4 lots of half base times height. Okay, so I've made a formula to fit my question here. Now L for my square. L is going to be this side length here. L, that one there. So that's going to be 6 squared. Plus, now I need 4 lots of my triangle. And I hit a few little problems here. Have a look at this triangle. If I take, this is my triangle here. Okay, I'm just taking one triangle there. My base is 6. That's all right. Where is the height? It's not the 9. 9 is the height of the pyramid, not the height of that triangle. You would use that 9 if it was a volume question. That would be the height for a volume question, but it is not the height of that triangle. Okay, so here comes Pythagoras' theorem again. I'm going to draw, and this is a little bit weird three-dimensionally here, across there, like that. Okay, because pyramids are hard to draw on a two-dimensional surface. Okay, that is my perpendicular height there, that 9 coming up. I've got the base across the bottom there. my perpendicular height, but I need the height of my triangle, which is actually the sloping one. Okay? So this one here is 9. The bottom. How long is that bottom, that green, the inside triangle there? What's the base of that triangle? I heard it. Someone said it. 3. Yes, this would be 3. Because even though it doesn't look like it, again, weird three-dimensional drawing, that perpendicular height would go to the base of that, straight to the center of that square. Okay, which means if it's 6 for my square length, it's going to be 3 for halfway, right? Okay, so using Pythagoras' theorem with the 3 and the 9, I'm finding the hypotenuse again. So let's draw a little arrow in here like we did last time. To find my hypotenuse, which is also happens to be my height. Hey, it's a good thing that we're using h for both of them, hey. All right, so then we have square root sine 9 squared plus 3 squared. And again, I'm just going to keep that exact just so I don't get any extra errors that I don't want. 9 squared is 81, 3 squared is 9, which makes square root of 90, just to keep it exact. Okay, so now I have the height I need. My triangle is half. The base of my triangle, I'm looking at the big, I'm going to draw it in red. I'm now looking at this big side triangle here. I'm not using my Pythagoras triangle anymore. I'm using this triangle. I want to find the area of that. The base of that triangle is 6. And the height of that triangle is what I just found, not the 9, that's the perpendicular. This sloping one here, which is the square root 90. That's why I had to find that. All right, close that up, type it all in. All right, that was a bit tricky, wasn't it? Over the page. Question 2. Everyone written that down? No? All right, I'll just wait a second. There's a couple of no's. All right, good? All right, question 2. A cone with a radius of 5 centimetres has a curved surface area of 140 centimetres squared. As soon as you read that, you go, it's giving me the surface area. That means I'm going to be working backwards. Okay, why are you waving at me? Oh, okay. All right, so the first part A says, draw a diagram of the cone. So I'm just going to draw a cone like this. Circly, flat kind of circly thing on the bottom. Yep. Do a perpendicular height coming down, just because we normally like to see that one there. My radius, which comes out that way, there's my radius. In the question, it tells me that that is 5 centimetres. And it tells me that the whole surface area, which I can't really write on my diagram very well, but my surface area is 140 centimetres squared. This one would be the H, which we don't use for surface area. We use it for volume. The S, the slant height, that's the one that we need. So part B, now that we've got a diagram with everything in the right places, part B, find the slant height of the cone correct to 1 decimal place. Start by writing the formula down. Oh, wait a second. Be careful. Let me have a think. This said I have the cone with a curved surface. Is that the whole cone? No. What part is that? The curved part, not the circle on the bottom. So when I'm writing my formula down here, I don't want to include the circle part. I just want the curved surface part of the formula. So that means I need the formula SA equals, not the circle, just the pi RS, just the curved surface part. Okay, reading the question for the fine details. Okay, the surface area we were told was 140. Pi is a number, we can know that one. The radius is 5, so times 5. And I'm actually trying to find that S. Do your best to make your S not look like the 5. Okay? before we do that in your calculator, let's practice with the exact part again. All right? If I have 140, I have 5 pi times by that s. Just in the start, there are questions that come out that you have to leave them exact. So when we get the opportunity, it's good to practice. If I wanted to get the s by itself, I'm going to go divide 5 pi, divide 5 pi. So there it is exactly. S is equal to 140 divided by 5 pi. Okay? But this question did ask for 1 decimal place. So you put that in your calculator and you get S equals 8.9 centimeters. Part C. Oh, sorry, you're right there. One last bit says find the height of the cone to 1 decimal place. That's the perpendicular height. That's that one that's actually h. Okay? Now this would be setting you up to then maybe you can go and find volume to use that little h. We're not going to go that far yet. We just need to find a little h. So from my diagram there, if I now know that this one over here is 8.9 centimeters, how am I going to find that perpendicular height? Pythagoras. Okay, so little h, which is, yep, because it is the height. However, it's not the hypotenuse. Does that confuse anybody? I'm calling it h because it's the height here, but it is not the hypotenuse of the thing that I'm doing Pythagoras Theorem on. Is everyone okay with that? All right, so I do still need to do my hypotenuse squared minus my shorter side squared. So 1 decimal place comes out as 7.4 centimeters. Your perpendicular height is always shorter than your slant height. Yeah? Any questions?